Let's get right to it. Time to get learning. You didn't think I was going to talk all the time, did you? In the near future, I'm going to be uploading the introduction to many of my courses from LogicBot. Now, it won't be the entire course, but it will give you a flavor of how the courses are structured and why you might want to enroll in LogicBot. I'll also group them in a way where you can watch all the material I upload for a given course. If you aren't familiar, a playlist and YouTube is nothing more than a group of videos that are related. For example, I'm going to start uploading the video for my course on Keras. Each video will be one lesson from the course. Thanks for watching. If you aren't subscribed, knock that out right now and have a great day.
Human brains interpret real-world situations in ways that computers can't. Neural networks were first developed in the 1950s to address this issue. An artificial neural network is an attempt to simulate the network of neurons that make up a human brain so the computer will be able to learn things and make decisions in a human-like manner. ANNs, or artificial neural networks, are created by programming regular computers to behave as though they are interconnected brain cells. Artificial neural networks use different layers of mathematical processing to make sense of the information it's fed. Often, an artificial neural network has anywhere from dozens to millions of artificial neurons arranged in a series of layers. The input layer receives various forms of information from the outside world. This is the data that the network aims to process or learn about. From the input unit, the data goes through one or more hidden units, or hidden layers. The hidden layer's job is to transform the input into something the output can use. The hidden layer is the computational layer. The input and output are not computational layers. They are simply layer to accept the data and output that data. In our diagram, the first layer shows the input layer. It's accepting data. It's accepting or being passed two pieces of data. The second layer is the hidden layer. These layers are the computational layers. The last layer is the output layer. It outputs the calculation done by the neural network. And our diagram represents the most basic artificial neural network that can exist. It is an artificial neural network with one hidden layer. All artificial neural networks are composed of artificial neurons. They are not only named after their biological counterparts, but they are also modeled after the behavior of the neurons in our brain. Like a biological neuron, an artificial neuron has several input channels, a processing stage, and an output that can fan into multiple artificial neurons. Let's zoom into this process a little further. How does a neuron process its input? There are three core processing steps. In the first step, a signal comes in and it gets multiplied by a weight value that's assigned to the input. If a neuron has three inputs, then it has three weights that can be adjusted individually. During the learning phase, the neural network can adjust the weights based on the error of the last test results. Step 2. In the second step, the modified input signals are summed up into a single value. In this step, an offset called a bias is added to the sum. The neural network also adjusts the bias during the learning phase. At the beginning, all neurons have random weights and random biases. After each learning iteration, these weights and biases are gradually shifted so that the next result is a bit closer to the desired output. This way, the neural network gradually moves towards a state where the desired patterns are learned. In the third and final step, the results of the neuron are calculated and then turned into an output signal. This is done by feeding the result into an activation function.